Welcome to your personalized deep dive. Today we're cracking open the world of Python programming.
Using those excerpts.
Yeah, using those excerpts from the Think Python textbook you provided.
It's a good one.
Yeah.
We'll uncover why Python is so popular, show you what code looks like, and even tackle debugging.
Ooh, debugging.
Because let's face it, everyone trips up in code, even us.
I have to admit, seeing Python's ranking on the TIOBE index steadily climbing makes you wonder what they've got that other languages don't. What's the draw?
It's a fascinating blend of power and approachability. Python's considered a high-level language, meaning it reads closer to plain English than the complex instructions computers actually use.
It's less like deciphering ancient runes.
Exactly.
More like writing a grocery list the computer understands.
Exactly. And being an interpreted language means you don't need a separate step to translate your code before running it. You write it, you test it, boom, instant feedback. Perfect for experimentation.
Okay, I'm starting to see the appeal. But the materials also mention Python being used everywhere. Data science, web development, even machine learning. How can one language be so versatile?
Yes, that's the beauty of it. Python's portability lets you run the same code on Windows, Mac, Linux, you name it. Plus, it's open source, meaning it's free to use and modify. That's fostered a massive community constantly building tools and libraries, expanding what Python can do.
So it's like a language that's constantly evolving, getting richer and more capable thanks to its users. Speaking of evolution, I was struck by something called the Zen of Python in these materials, almost like a philosophical guide for programmers. Is this common in the coding world?
Not really. The Zen of Python is unique. It captures Python's design philosophy in these short aphorisms that guide you towards writing code that's not just functional, but also elegant and readable. It emphasizes clarity and simplicity.
Like beautiful is better than ugly. Right, I saw that one.
Yes.
But how does that translate to actual code?
It's about prioritizing readability. For example, instead of cramming everything onto one line, you break it down, add comments explaining your logic, making it easier for others and your future self to understand explicit is better than implicit. Another Zen principle reinforces that.
Okay, that actually makes a lot of sense. It's like the difference between a messy handwritten note and a well-organized document. You might understand both, but one is way less painful to decipher. So assuming our code is now a work of art thanks to the Zen of Python, how do we even start running this stuff?
You have options each suited for different tasks. The Chevron prompt is your go-to for quick calculations and testing small code snippets. Think of it as an interactive Python calculator. Then there's Jupyter Notebook, excellent for learning and experimentation, where you combine code output and explanations all in one document.
Ah, Jupyter Notebook. I've heard data scientists rave about those. But for building something bigger, a whole program, that's where Python scripts come in, right?
Exactly. Scripts are separate files containing your code, which you can execute independently. It's like writing a complete recipe the computer can follow.
Now, I've got to be honest, when I first dabbled in coding, the number of errors I made was impressive. Is there a trick to avoiding these bugs, or is it just part of the process?
Debugging is the process. Even seasoned programmers hit snags. The key is understanding the types of errors. You have syntax errors, like grammatical mistakes in your code. Then there are runtime errors. These pop up when the program's running and encounter something unexpected, like trying to divide by 0.
So syntax errors are like forgetting a comma, and runtime errors are like hitting a pothole on a smooth road trip.
Perfect analogy. Then there are semantic errors where your code runs fine, no complaints from Python, but the output is just wrong. That's when your logic needs tweaking. But remember, error messages, while frustrating, are actually clues pointing you towards the solution.
Okay, that's oddly reassuring. So once we're past the bug squashing phase, what are the core elements of a Python program? What kind of data are we playing with?
At its heart, Python manipulates data, the most basic types being numbers and strings. Numbers can be integers like whole numbers or floats, which handle decimals. Strings are sequences of characters like words or sentences, always wrapped in quotes.
Got it. So someone's age would be an integer, their name a string. But what if I need to store, say, the price of something, which usually has a decimal?
That's where floats come in handy. They allow you to represent numbers with decimal points like 99.99 or 3.14. And what's cool is Python often figures out the data type for you based on the value you assign. This is called dynamic typing.
Wait, so I don't have to explicitly tell Python, hey, this is a number, this is text?
Not always. Python infers it, which can save time. For example, if you assign the value 3.14 to a variable, Python automatically recognizes it as a float. However, understanding data types is still crucial because they dictate what you can do with that data.
Right, you can't really add someone's name to their age, even if Python's super smart.
Mm.
So to store this data, we use variables, if I remember correctly. Are these like the x's and y's from algebra class?
Think of variables as containers for your data. You give a name to a value, and Python remembers it. For example, you could store someone's age in a variable called age and then easily reference it later in your code.
So variables are like labeled boxes where I can put different pieces of data, and Python keeps track of what's in each box. But how do we tell Python to actually do something with this data, like perform calculations or make decisions?
That's where expressions and operators step in. Expressions combine values, variables, and operators to compute results. Operators are symbols like the plus sign for addition or the asterisk for multiplication.
So if I wanted to calculate someone's age 5 years from now, I'd use an expression that adds 5 to their current age, which is stored in the age variable, right?
Precisely. And just like in math class, the order of operations matters. Python follows PEMDAS, parentheses, exponents, multiplication, and division from left to right, and lastly, addition and subtraction from left to right.
Ah, PIMDAS, the order that never changes. But let's be honest, most programs aren't just about crunching numbers. How do we make Python interact with the user, get their input, and display results?
For that, we have the dynamic duo, print. An input is your way of displaying information to the user, like showing the result of a calculation or asking a question. Input allows you to receive information from the user, like their name or a number.
So print is like our virtual megaphone, and input is our way of listening to the user. I remember that Think Python excerpts had a simple example where the program asked for the user's name and then greeted them personally.
Yes, you'd use input to get their name, store it in a variable, and then use print to display a message that includes their name. You can even get creative with escape sequences to format your output nicely. For example, submit creates a new line, making the output more readable.
Okay, so we're having a conversation with the user, making our program more dynamic. But what about making it smarter? Can we teach Python to make decisions based on different situations?
Absolutely. That's where conditional execution comes into play, specifically using if statements. An if statement evaluates a condition, and if that condition is true, it executes a block of code.
So if I wanted the program to say good morning only if the time is before noon, I'd use an if statement to check the time and execute that greeting only if the condition is met.
Exactly. You can also use else to specify what should happen if the condition is false. In this case, you might have an else block that prints good afternoon if the time is noon or later.
It's like giving Python a tiny brain, letting it choose the appropriate action based on the situation. This is starting to feel like real programming. But what about when we need to repeat a certain action multiple times? Do we have to copy and paste the same code over and over again?
Not at all. That's the beauty of loops. They let you execute a block of code repeatedly, either a set number of times or as long as a specific condition is true.
That's incredibly efficient. I can imagine this being super useful for tasks like processing a list of names or calculating a series of numbers.
Exactly. Python offers two main types of loops: for loops and while loops. A for loop is used to iterate over a sequence, like a list of items executing the code block for each element in the sequence.
So if I had a list of student names, a for loop would let me go through each name and say, print a personalized greeting for each student.
Precisely. A while loop, on the other hand, keeps running as long as a certain condition remains true. Think of it like a game that continues until the player runs out of lives or reaches a certain score.
Got it. So loops are like automation tools, handling repetitive tasks with ease. As our programs grow more complex, how do we keep the code organized and manageable? I can only imagine how messy things could get.
That's where functions come in. They're like reusable building blocks for your code. You encapsulate a specific task or set of instructions within a function and give it a name. Then you can call that function whenever you need to perform that task instead of rewriting the code every time.
So if I had a program that frequently needed to calculate the area of a triangle, I could create a function called calculate triangle area and simply call it whenever I needed that calculation, right?
Exactly. Functions make your code more organized, readable, and efficient. They also make it easier to collaborate with others, as each person can work on different functions and then combine them into a cohesive whole.
It's like assembling a complex machine from well-defined parts, each with a specific purpose. This modular approach seems crucial as programs grow larger and more sophisticated. This whole deep dive is making me appreciate the elegant structure and thoughtfulness behind Python. It's more than just throwing code at a computer. It's about breaking down problems and crafting logical solutions.
That's a great way to put it. And remember, what we've covered is just the tip of the iceberg. Python has a vast ecosystem of libraries and frameworks that extend its capabilities even further.
Yeah, it's like we've unlocked a whole new way of thinking, a way of approaching problems with a clear, logical mindset. And the Think Python excerpts with those end-of-chapter
Oh,
exercises,
yeah.
it's like having a training ground to
Right.
test out these newfound skills.
Those exercises are fantastic for solidifying your understanding. It's one thing to grasp a concept theoretically, it's another to put it into practice and see it work. Don't be afraid to experiment, make mistakes. That's how we learn.
And maybe even stumble upon some unexpected applications for Python along the way. I'm starting to see how this language can be used in so many different fields.
Absolutely. Python's used everywhere from web development to data science, machine learning, even creating video games. Its versatility is one of its biggest strengths.
This deep dive has been incredibly insightful. I feel like I've gone from zero to Python hero, at least in terms of understanding the fundamentals. But before we wrap up, any practical tips for someone just starting out? Where should they go to explore further?
There's a wealth of resources online. Websites like Codecademy and Khan Academy offer interactive Python courses for beginners, and platforms like Hadis provide coding challenges to put your skills to the test. Of course, there's always the Think Python textbook you provided for a more in-depth understanding.
It's like having a whole toolkit at our disposal. And as we tinker with these tools, maybe we could even sprinkle in some of that Zen of Python wisdom. Not just for writing elegant code, but for approaching life's challenges with clarity and simplicity.
That's a beautiful connection. The principles of the Zen of Python, like striving for readability and simplicity, can be applied far beyond coding. They encourage a mindful approach to problem solving, seeking elegant solutions, even in everyday situations.
It's almost like a philosophy for life.
Hmm.
This has been a truly eye-opening deep dive. Thank you so much for guiding us through this fascinating world.
It's been my pleasure. Remember, the journey of learning is ongoing. There's always more to explore, new challenges to embrace. Keep that curiosity alive and enjoy the process.
Well said. And for our listeners out there, keep in mind, this is just the beginning of your Python adventure. The possibilities are endless. The only limit is your imagination. Happy coding, everyone.